And presentation. All right, so I might not be able to see the Teams chat. Well, Adam, are you connected on that?
Yep.
Thank you all for coming. I'm a little soft spoken, so please let me know here if anyone has trouble hearing me, just speak up. My name is Allie Holdhusen. I work for the Mississippi National River and Recreation Area. I'm a biological science technician and a program dive officer for the Great Lakes Big Rivers Dive Program. I'm very happy to be here today to speak with you all about one of my favorite species, or faunal groups, I should say. And it's been a long time since I've given a talk, so I thought I'd embarrass myself up front by showing off some of my meeting doodles of little clams. Real clams don't have cute eyeballs.
Oh.
But, you know, I thought I'd just embarrass myself up front and get that over with, and we'll see if all my neat videos and stuff work as we go along. And I thought I would start with this, just kind of showing everybody kind of what it looks like to work with mussels in the national parks, while I kind of introduce myself and give a little background of what I'm talking about today. So I work as a biological science technician in the field with many different species, from river otter and coyote, songbird, frogs, all sorts of different species depending on the season. My favorite thing to work with is definitely mussels, mostly because I find them endlessly fascinating, and I feel like I'm always constantly learning something from them. They're just so diverse and complex, and their natural history and life history is just really interesting. So today I'm hoping to show you all why mussels are important to the river ecosystem and to us, as we're all interconnected, and why they're valuable to us. And I'm hoping to just show everybody what I've learned, that if we watch and listen and learn from river mussels, that they actually have a story to tell us, and that they can tell us a lot about the river. So these are just some videos of diving in different parks in the Great Lakes region. This last one is the Mississippi River, and you can notice how kind of hard to see. So river mussels are freshwater clams. They're related to snails, saltwater clams, octopi, squid. They exist globally. There are 900 species of freshwater clams in the world. North America actually has some of the richest diversity of mussels in the world. There are 300 species in North America alone, and over 50 species in the upper Mississippi River Basin. The Mississippi National River and Recreation Area has 29 of its original 41 species. Our neighbor sister park, the St. Croix National Scenic Riverway, has 41 of their original 41 species that are still persisting today, that were here prior to European colonization. So in terms of global diversity, these two parks are really special to the global assemblage of mussels. Interesting fact that 1 meter square of river bottom in the southeast part of the United States actually has more species of mussels than the entire continent. So just to exemplify how rich North American mussels are in diversity. 5 of these species shown here are federally endangered mussels that live in the St. Croix National Scenic Riverway. And from on our left here, let's see if the little laser pointer works. This is the spectacle case mussel.
Or the what kind?
Spectacle case.
Okay.
They're very large and they live to be over 100 years old.
Wow.
These are Higgins eye mussels. They have been reintroduced to the National Park in the Mississippi River.
Oh.
And have recently been shown to be reproducing again naturally, which is a huge success. This is the sheep-nosed mussel, another federally endangered species that we work with. The snuffbox and the winged maple leaf. These are all common names for these endangered mussels that we have. And as diverse and interesting as all these species are, they're also the most imperiled faunal group in the world. It's said that between 60 and 70% of mussel species are extinct or at risk of extinction. So if you think about it, that's more, you think of amphibians as being really vulnerable. Mussels are quite a bit more at risk than those even. Here in North America, 76% of our mussel species are imperiled. And this is largely due to overharvesting in the early 1900s. They were harvested for their shells and the pearls that they produce. I don't know if you can see this here, but it shows someone making buttons out of shells. And so European colonizers, settlers in the early 1900s would just wipe out entire stretches of river. Also, the construction of dams and pollution in the early part of the 20th century really harmed mussels, and that is the reason they are at there. Interesting though. So river mussels are also known as the freshwater equivalent of a coral reef.
Oh.
They stabilize the river bottom with their shells, live and dead shells. And this reduces erosion and enhances habitat for not only more mussels, but fish and invertebrates as well. They're food for a variety of mammals and fish that eat them. And these diagrams kind of show how mussels can link food webs between they filter water, that's how they feed. And they take nutrients out of the water column, secrete them as waste, and that waste is eaten by vertebrates and fish. And their shells create habitat for fish eggs and snails and other vertebrates. So it's really through this habitat modification of the mussel bed that we get this coral reef. It's just stimulating more and more production, creating habitat for more mussels, more fish. Not the laser pointer anymore. There we go. So this is a video showing some of that filtration, and it not only creates a link in the food web and better habitat on the river bottom, but that the way that mussels eat also cleans the water. That benefits us. one mussel can filter up to 10 gallons of water a day.
Really?
This is a fast motion video I took a few years ago, just showing what one little tank of mussels can do in a span of like a half hour. So you can imagine what an entire river full of millions of mussels could do. And studies have shown, they've tried to quantify and put a value on that filtration service that these mussels do for us. And one study showed that 450 miles of the upper Mississippi River did a population estimate on the number of mussels there and estimated that they were filtering 16 billion gallons of water a day. And if you compare that to the Minneapolis wastewater treatment plant, that's quite a lot. That's a huge service that these mussels are doing for us for free. Here's some up close pictures that I took this past season of just some filters. You could see this is the in current siphon where the mussel sucks up the water, and the out current siphon where it excretes the water as clean water, and it filters it with its gills. In Philadelphia, they're not only imagining what an entire riverbed of mussels can do, they're investing $8 million in restoring 500 million mussels to their riverbed by 2023 to see if that can create fishable and swimmable river and estuary system in the Delaware River. No, this is not a weird sci-fi movie. These are actually mussels that have been called for a different service to humans. They are being used as indicators at wastewater treatment plants. Mm-hmm. So mussels, because they're eating water constantly, they're also very sensitive to contaminants and pollution. So when a river mussel is feeding and it senses something that is toxic to it, it will shut its shell and literally clam up. So these wastewater treatment plants have done lots of studies and figured out how to tie sensors to the mussels that trigger an alarm inside of the wastewater treatment plant, signaling that that's something to investigate. Something might be contaminating drinking water. So in addition to all these services that the mussels provide to the river, us, and the entire ecosystem, another really, really neat thing is just their life history. So river mussels depend on fish to reproduce. The fish are hosts for their larval stage of their growth. Kind of like a butterfly, but in reverse. So a butterfly seeks out its plant and the plant stays still. But this mussel has to stay still. So it attracts its host with different adaptations, like physical lures that they stick out of their shell. And it attracts the host fish that comes and bites down on this lure. And the mussel can sense that fish coming so close, and it blasts its larval muscles, known as glochidia, all over the fish. They attach to the gills. There's different adaptations morphologically in the larva. So ones that attach to the gills look kind of like this with a flatter shape. And ones that attach to the fins have these like vampire teeth. Here's a video I hope works to show you just kind of what that looks like in action. This was the best video I've seen so far by Brett Billings and Brian Haggerty. And you'll see how this mussel is literally mimicking the fish's prey in order to use that fish as its host. There's lots of neat videos like this online. I encourage you to look deeper into it. Another really cool one is the snuffbox mussel, which looks kind of like one of the paintings on this big Greenway mural, the snuffbox mussel traps its host's nose inside of the shell, bites down on it until the fish is blasted with its larval Lochidia babies, and then it lets it go so that it can swim away. And why do the mussels do this? Well, if you're stuck sitting still, a mussel doesn't move much more than about 5 or 10 feet yards in its entire lifespan, and they live up to over 100 years. So in order to get upstream, they have this amazing adaptation to use the fish as their ride upstream. And just in case that video didn't work, and because this is super neat, I found this mural that's in Tennessee by artist collective called Just Seeds. And they made this huge diagram of this entire life process. So I thought was cool. I think Minneapolis needs it.
When the lochidia are attached to the fish.
Yeah.
Is it only for transportation purposes, or are they also getting nutrition from the fish?
That's a great question. So Brian asked if the only reason that the Glochidia use the fish is for transportation. And the answer is they are also using the fish as a way to get nutrients. And so ones that are attached to the gills in particular are also getting oxygen and nutrients from the water while they're stuck there growing. And so they grow there for a certain point until they mature into more of a adult shape, and then they will drop to the river bottom until they reach their first year or two maturity.
So they're not parasitizing the fish. They're not drawing blood or anything.
I don't think so. I know that they are parasitic in a way that they feels like the fish sort of has a cold. But fish are sort of naturally immune to the mussels attaching to them. That doesn't really kill them unless, in some instances, in artificial area like inoculations, you can over blast a fish with mussels and it'll die. But in nature, that doesn't really happen very much. It's kind of just like some Glochidia attach for a week or two and some over winter. So depending on how long that species stays with the fish just kind of feels a little run down maybe, but not really severely affected. And so we river biologists and everybody that lives on the river can really recognize the importance of mussels for the health of the river as indicator species, their dependence on host fish and sensitivity to pollutants, and their reliance on quality, water quality, and robust river habitats make them an indicator species. And biologists have recognized this. And because they are so imperiled, have really started a strong cohort of partnerships in the Upper Mississippi River Basin, known as the Mussel Coordination Team. That includes the Army Corps of Engineers, Mississippi National River and Recreation Area, the St. Croix National Scenic Riverway, the U.S. Fish and Wildlife Service, U.S. Geological Survey, Coast Guard, DNR from Minnesota, Wisconsin, Iowa, Illinois, Missouri, as well as colleges and universities, and environmental consulting firms. So we all work together, all these mussel specialists, to monitor mussels and also help them through that reproductive cycle, and also improve their habitat and water quality. The Mississippi National River and Recreation Area is sort of special in a way because it creates sort of like, it's not quite as pristine as the National St. Croix National Scenic Riverway. But the habitat's pretty good. We have a lot of our species have come back since that turn of the century. And the water quality seems just good enough that species are able to come back and return. And there's something about whether it's the flow or the water quality or the lock and dam system or something, but zebra mussels also don't seem to be taking a hold in the Mississippi National River and Recreation Area like they do downstream in other pools downstream.
It's not the cold, it doesn't have an effect.
The temperature, the question was, does the cold have an effect on why the zebra mussels don't take a strong hold? And temperature does play a role in it, but it's not completely understood yet how much that comes into play. So it does make our park really special in a way that we are able to expand some of these endangered species ranges back into our park. Lots of reintroductions and releases happen in our park. Here's just a few numbers from the past few years. And some species we've been seeing reproducing naturally again in our park, like Higgins eye, which is a federally endangered species, and some other threatened and endangered or special concern species, like the pistol grip and the butterfly shown here on the bottom left. And in the middle here, you'll see a couple really old washboard. The washboard. This mussel was like over 50 years old or something. It reintroduced there 20 years ago. We picked it up again. And the way that they create these, or the way that these releases happen is through partnerships with hatcheries. And here you can see the Minnesota Zoo has their own mussel propagation bucket system that they put off of their dock. So if you ever want to go learn about mussels and see them up close, see how the propagation happens, you can visit them. Some of those mussel babies that they raise get released back into our park. This is a winged maple leaf that was raised in the St. Croix National Scenic Riverway, along with several hundred others that were found at the same time and all released back into the national park. And we also monitor them and look for things like changes in abundance, species distribution, age classes. So if some areas of the park are all older mussels, like those really old ones, they don't have any younger mussels reproducing. That kind of shows us that something's going on. The younger life stages of the mussel, they're much more sensitive to pollution and other disturbances. So if you suddenly see a large change in the age distribution in a group of mussels, that might show that something's going on with the habitat or the water quality that needs to be addressed. And to do this, we search hundreds, I think there was about 160 different sampling sites all up and down their park, sampled both in about 2001 and again in 2017. And we go down with these metal quadrats and we measure the substrate. We take all the substrate and the mussels, put it in a bag, bring it back up, and ID everything in there. And it gives us an overall idea of all the mussels in the entire park.
Excuse me, how long can the mussels live outside the water?
The question was, how long can a mussel like this on the table here survive outside of the water? Most mussels will be fine for about the half hour that it takes us to ID and count them. Some smaller ones or thinner shelled species are very sensitive and might start to show signs of distress after about 10 minutes or so, depending if it's a hot day or something. So we just try to keep an eye on that when we're doing this, and we'll keep some buckets of water nearby just for smaller ones or anybody that looks like they're having a hard time.
How do you tell a stressed mussel?
Well, actually,
they
so they keep their shells shut when they're on the surface, and some mussels can survive that way for days or weeks even. As a natural way to survive drought.
Oh.
What they tend to do is want to bury themselves back into the sediment, so they'll stick their foot out and try to start digging back down. But if they get stuck behind a rock or something and they can't move, they just clam up and wait there. They hold whatever water they have in their shell, just like that.
Huh.
So when a mussel's distressed, it'll start to open. It starts to like lose its strength, and its shell just starts to like open up, and it's like they call it gaping open. So mussel starts to look like it's losing its energy, and you know that it's really stressed out and needs to get back into water. So yeah, these kind of surveys really tell us a lot about our park. It shows us where like there's hot spots for mussel diversity, quality habitat. We use that information on where to release those endangered species back to the park. And a lot of that depends on where they are in relations to locks and dams.
Oh.
Another thing that locks and dams do is they will sometimes prevent the habitat connectivity of that host fish. And a really good example of this is the spectacle case mussel that I was talking about earlier. Their host fish was identified to be one single fish called the moon eye. And the reason they found that out was because they had spent over 50 different species, trial and error, trying to figure out what the host fish is for this endangered species so that they could start trying to revamp the population through artificial propagation, basically. And the clue was, well, what the mussels exist above the dam, right? But they're not as common below the dam, or they're not as common above the dam anymore. All the ones above the dam are really old, hundreds of years old, like this picture. Below the dam, we're still finding them, and there's some younger ones that looks like they're reproducing. So what's the difference between the habitat above the dam and below the dam? That fish wasn't getting past the dam anymore. And so what we see is this huge difference in ages here. So now that they know the host fish, they can start trying to propagate them in laboratories and hatcheries, like some of those other mussels that we have that information for already. And a really good example of how this takes place, I can show you all, and I'll do it as fast as I can because I want to leave lots of room for questions. But I had this amazing work day a couple years ago where in one field day, I got to see like the entire cycle of how the propagation of the mussels happens. And I took lots of pictures, and I was like, well, let's just go through a field day and we'll show you how it all works. So, so we find these brooding female mussels. They only reproduce in a certain 2-week, give or take, window in the fall.
In the fall?
Yeah. And their host fish will get attracted by this lure. So that's how we find them, and we know that they are gravid with their glochidia and they're brooding. And we will collect that, put it in a tank, maybe overnight at most, until a biologist can come and meet us with to transport it to a lab. And we will take that glochidia. First, we take a little pipette sample, put it under a microscope, and you add a little bit of salt water to the slide, and it shows whether the glochidia are viable or not. Because once they sense that salt, that's like seeing a fish. That's like getting in contact with a fish. That's their one chance at life. So what do? They clamp shut. And so that salt shows you if those glochidia are ready to be attached to a catfish. So that one little sample has maybe, I don't know if you can see this, but you can see under the microscope some of these little open ones.
Oh, yeah.
And some are closed. So if they all stayed open, it would mean they weren't ready to be put on a catfish. So here's my colleague, Mark Hovey, looking under the microscope in the field. And
excuse me, is the catfish their normal host fish?
yes, So the
Oh,
particular
for this
species,
particular
the winged
mussel.
maple leaf, their main
Okay,
host is the channel cat.
okay.
And this day was super cool because this was the first time I had ever seen, and maybe ever, that we'd actually inoculated catfish on site in the wild. So these catfish were caught the day before or that day and were surgically put radio transmitters into the catfish so that scientists could detect them later on. So this is what those transmitters, we have these in the bottom of the river, so they ping when a catfish swims by. So we've got these catfish that we know where they're gonna go. We've got mussel glochidia. We've got Shelley Barsh rolling up with the boats full of giant catfish, ready to be inoculated with glochidia. Let's go.
Hmm.
And then, so those particular catfish were released back into the wild. And so this was kind of a new experiment. This species of mussels is really hard to get the babies to survive in these, in the hatcheries, in the lab. So they thought, why not try seeing if we can see where the catfish go back and monitor those overwintering sites and see if we can just find any young juvenile winged maple leaf that dropped off those catfish. And you could eventually link those quite genetically because you would take a genetic sample from the female that you collected from originally. Once you find a juvenile 5 years later, you can take another genetic sample and you, because this particular species only exists in this one stretch of river, it's really important to know the genetics of what we're reproducing in the lab so that we're not creating a genetic bottleneck. But this past year was also a really interesting success because for the first time, they were able to successfully reproduce over 100 juvenile baby winged maple leaf, not in the hatchery, but in this remote trailer, bioassay trailer that they set up. So it was set up right near the river and was being pumped with river water as close as they could get to where that species lives. So it was actually being fed the same exact water that the naturally occurring species were getting. And they were able to successfully raise 100 individuals.
Is this just last year?
Yes. And that's work that was done with that big partnership, but also like mainly our USGS partners. So that's kind of what the remote bioassay trailer lab looks like inside. We've got these buckets that are just flowing fresh river water all the time to keep these mussels alive and feeding off of their natural habitat, but safe from whatever environmental like threats are impeding the population from reproducing naturally. So if we can keep augmenting the population and improving their distribution, expanding their range into the Mississippi River, all of this is buying the species time so that we can figure out what's going on that's causing them to decline. And I will end just with this neat video of thing that works. So what happens when your colleague, Mark Hovey, tells you to go night diving with holding a cage full of chicken liver? So this was a project they were trying to film in order to better understand the interactions. They were trying to film catfish interacting with brooding females. So I went with him to help. So notice how excited we are at the end. So one of the host fish actually came right up to us underwater during a night dive.
Hey, what you
It looked even bigger underwater. That was so cool. That was so cool. Yeah, he was trying to film these he works with the University of Minnesota and McAllister College, studying the interactions between catfish and this endangered species. And he'd been trying for at least 2 years to film them in in the wild.
Mm.
And this was the first time he got one on camera, so he was super pumped. So I'll end on that exciting note and just want to thank you all for listening and open up for any questions you might have. Yes.
When you talked about the excrement from the mussels, you know, we think of excrement as pee and poop, but for a mussel, but you said it's clean that they're excrementing, but is there also poop in there, or what are they really?
The mussel poop is kind of like really rich fertilizer or something to other insects and fish. So if you're, you know, I don't know a whole lot personally about the nutrient dynamics that happen there, but I know that it sort of enriches the food web. So
Okay,
it creates food for insects and then creates food for fish. So it attracts.
so the
more
fish could eat the excrement.
Yeah, some might,
Okay.
you know, like bottom feeder fish might. Or,
Okay.
I think also attracts like smaller insects, and those insects attract more fish,
Okay.
and the fish help the mussels reproduce, and it creates this whole feedback cycle where you have kind of like this coral reef effect. Yes.
There's one from the chat. Lynn's wondering, did the native peoples eat mussels?
Yes, they were before. Well, yes, so they were one of the original food pieces for indigenous people, and some tribes still celebrate that and like in ceremony, and they will eat freshwater mussels as part of their original. I don't understand it a whole lot, but yes, they were a natural food source, especially in like harder times, I think. So you'd smoke or dry them out and kind of eat them when fish weren't as abundant. They were also used by Native and Indigenous people for jewelry, pottery, probably all sorts of things. It was just kind of like one of the natural parts of the ecosystem that they were part of. So.
You had mentioned, I think it was in Delaware River, they were going to start reintroducing them. Where were they going to get that many mussels from? Do you know?
So the question was back to the Delaware project that was trying to reintroduce 500 or 500,000 mussels by 2023. Where are you going to get 500,000 mussels? And so that $8 million project was to build a hatchery. And then the other 2 million like was going to come later down the road, but that was like the startup cost for this like really awesome hatchery that they're making apparently. First of its kind project. I thought that was really interesting. Yes.
Which dam was it that the Moon Eye was stuck behind?
The St. Croix Falls Dam near St. Croix Falls. The question was which dam were the Moon Eye impeded by?
When you see freshwater pearls, yeah, advertised like in a jewelry place, where are they? Do you know where they're getting their freshwater pearls from? Because there's no commercial production anymore in the United States, or is there? Of freshwater mussels.
The question was, so when you see freshwater pearls advertised for sale, where are they coming from? Because aren't freshwater mussels protected from that kind of harvest? And I think in most water bodies, the mussels are protected in the United States. However, I did hear, which I don't know if I'm remembering right, but one of the common species called three ridge that exists in our park might still be commercially harvested and like exported to other countries to make artificially transplanted freshwater pearls for
Oh,
sale. So that's one example, and I don't know a whole lot about it personally, but I think, yeah, they can. Yeah, they must either get them from someplace where they're not protected and rear them in a hatchery and artificially transplant pearls into them, or like grow their own mussels from scratch.
okay.
I guess.
What other projects are you working on here in the near future?
Let's see, so a big one is, so some of the threats now, we don't have, they are protected. We aren't harvesting them for pearls. We're not harvesting them for buttons. But some of the biggest threats that we're facing today are things like climate change and the expansion of invasive species like zebra mussels. So one of the big projects I'm working on this year is helping with Great Lakes area project to monitor zebra mussel expansion in the Great Lakes, which are threatening native mussels in those areas. And let's see, that's my big project this year. A lot of the stuff that we're working on lately is monitoring like places called essential habitat areas. So from all these monitoring efforts, we've identified these key habitats like St. Croix and the Mississippi River. And we go back every 2 to 5 years or so, and it rotates from park to park. We'll go back and monitor those areas, sometimes do reintroductions and things.
There's a few more in the chat. Linda's wondering if you've found any microplastics in mussels in the work that you've been doing.
Question.
It was 2016 or 2017. I did help collect mussels for a microplastic study. And yes, mussels have microplastics.
Huh.
I personally haven't worked on anything relating to that recently since then. But I know it is a field of mussel studies, seeing how mussels bioaccumulate microplastics as part of the. So they're in there.
There's one more in the chat from Len. How close are mussels and clams genetically, i.e. The same breeding and life cycles, etc.?
Oh, that's a good question.
Can you repeat that one more time?
Yeah. How close are mussels and clams genetically, i.e. are the same breeding and life cycles, or is it?
Mussels and clams, I think the term can be used interchangeably.
Mm.
I'm assuming that they mean like the difference between freshwater and saltwater mussels, or bivalves. So they're all the same fauna, just two-shelled organisms. And how close are they genetically? So like a freshwater and a saltwater clam could not reproduce. If that answers the question.
I think it's just like how similar are they? Like asking about like the life cycle and breeding and like, do they have probably similar physiological properties and stuff like that?
Yeah, unfortunately, I don't know a whole lot about saltwater clams. I have a lot to learn in that area. But I do know that not all clams need the host fish to reproduce, that might be sort of unique to freshwater mussels that live in rivers. So something like that would be more common and necessary in river mussels than it would be in saltwater ecosystems. And yeah, I would have to look into that more because I don't know a lot about saltwater ones.
You mentioned there were several predators to mussels at the beginning. You said both mammals and I think fish, did you say?
Yes.
Okay, what are the primary mammals? I assume otters is one? Or no?
Yes.
Okay, and then what other mammals? And then are there certain fish that are more likely to be predators to mussels or just all
Yeah,
fish?
that's a good question. So Mary was asking, which, mammals feed on mussels, which would be most like semi-aquatic, carnivores would, I think, so. Or omnivores, like muskrats are a big
Oh.
predator for mussels. They
Okay.
create like middens on the shoreline, so if you ever walking down the river and you see a big pile
Oh.
of mussel shells, it's often left there by muskrats.
Oh,
River otter feed on mussels as well. And yes, a lot of fish eat mussels too. And I don't know enough about fish predation to know which species of fish eat mussels more than others. But I know certain fish have different physiological things that help them like grind down the shells and things.
oh, because they eat the whole shell? They don't pry it open? Well, I guess the fish couldn't
Yeah,
pry it
fish kind of
open.
like cut it open.
Oh,
But yeah, they're eaten naturally by lots of different. Oh, Michelle chimed in. Some of the common fish species that really enjoy eating mussels are freshwater drum and red horse. Thank you, Michelle. That's Shelley. She works with the USGS. I work with her a lot.
red horse.
She knows a lot about fish, a lot more than I do. Glad you're on the call, Shelley.
With the closing of the upper or the St. Anthony Falls lock and dam, have there noticed any, hasn't been that long, but any loss of like fish movement and stuff like that up and down or between like the lower St. Anthony Falls pool and above the falls there? Is that something you looking into?
Red horse.
That's something to look into. We're hoping to start a project with that in the next couple of years, funding pending. But that stretch of river is historically hard to look at because between the two lock and dam systems, it's really fast currents, really hard to scuba dive in. But interestingly, in 2020, to do some maintenance on, I think, the dam and the bridge, they lowered the water
Yeah.
way down. So all the mussel biologists were able to get in there and save all the clams that would have gotten stranded by the low water. And by doing this, we actually got a way better idea of the species in that pool than we ever did scuba diving because it's just so dangerous to dive in. And I know historically above the falls, there was like 18 species. And I'm just gonna look back to my notes here. I have an interesting number to answer your question. But so there's like a huge difference above Coon Rapids Dam. They're seeing like bigger declines, there's less abundance, less species diversity. Below the falls, it's just I just want to pull up this. Oh, I guess I can't. But it was something like, so, oh, here it is. So before 1900, there was 9 species above the falls and 43 species below. Who wants to guess how many mussels there were in the early 1900s?
Oh,
Any guesses?
19. You mean how many sheer numbers?
Mhm.
A billion.
0.
Oh, really?
And in 1972, there were 7 species below the dam
Oh, yeah, that.
And in the early 2000s, there was 28 species downstream of the dam and 18 species above. And today there's 29 and 18 above. But that whole reach is sort of like seeing some of the biggest changes that we saw in those like park-wide surveys above and below. And that particular stretch is harder to monitor because of the conditions. And there hasn't been any studies looking at the effects of that lock closure yet. So we don't really know what that's done in terms of how does that affect the dams tend to affect both the temperature, the flow, the amount of sediment that gets through below them. So it can really not only affect the things above it, but also below. And so looking at how all that comes into play, I think will be important because it's such a huge change. Yes, do you have a question?
How far north do you find mussels? Like, do you find them on the Yukon or the Noatak or Kobuk or
How far north in
north can
Minnesota?
you, no, in North America?
In North America? Oh, gee.
I guess, are they found in the upper Mississippi River? Maybe be a better question.
Yeah,
Like in Itasca as an example.
yeah, they do occur like statewide, so like.
Oh, they
the
do.
Red River Basin, and the Great Lakes,
Okay.
and they exist.
But is there an upper limit to where they can survive? Do you know?
Not that I know of, but I know that like in northwest part of the United States, like their diversity is closer to like 5 species or something.
really?
So, they're not as diverse and rich as they are in this particular area in most cases. So really the hotspots are here and Southeast United States. And some colleagues and I were just talking about how they went to like some workshops down in Tennessee and just like how much their numbers are declining in that Southeast region. And that's not happening here as dramatically as they're seeing in some of those Southeast regions. So it just makes these populations even more special.
Are our lake mussels any different than our river mussels?
Yes. The lakes have a lot less species in them, and I've just started recently working more with like Great Lakes mussels. So we'll find maybe like 2 or 3 species on a survey, and they're all kind of they have just lower diversity. They seem to have like thinner shells. And I don't know enough about it to say like off the top of my head which species those are or what their host fish are or what some of the different habitat adaptations are for those. But all of those things would be like entirely different from a river mussel. Not entirely, but you do see some dramatic differences in just the physiology and
What makes up a shell? Oh, I'm sorry, I thought you were done.
go ahead.
What makes up the shell? I mean, what is it, calcium or what is made of?
Mussel experts on the call that know what mussel shells are made out of. Calcium carbonate.
Oh.
Thank you, Shelley.
Okay.
That's something that grows with them as they age. They don't move around or change. Yeah, that's something.
Yeah, they keep their shells, and an interesting thing is that they have like growth cycles.
Yeah, I've
Actually,
seen
the way we find out the ages of them is similar to counting like a cut tree.
Yeah.
So you count the rings on their shells, see how old they are. So they grow faster when they're young, so it'll be like 1, 2, 3, 4, and then once they get past like 12 years old, it's like 20 years of rings
Okay.
in like this far of a space on their shell, and you're trying to like count them and magnifying glasses.
Teenagers.
You're like somewhere between 40 and 70, I have.
1 o'clock.
1 o'clock. Well, thank you all. And I put my email on that last slide. If anyone has any questions that come up, please feel free to contact me. There it is again, Allison. I'll put it in the chat too. Thank you all.
Thanks,
Thanks,
Allie.
Allie. Thank you.
That was really good.